Oh, okay, yeah, thank you very much. I'm in a room that is on fire, both in temperature and in virtual Zoom background. So let me just share my screen and then get my context set up correctly. All right, yeah. So hello everybody. Am I the first? Am I the first speaker actually from Newcastle? I think I might be. Yeah, so I'm going to be talking today about security in CI/CD pipelines. This is mostly based off my experience in some previous jobs, some things I've picked up along the way. Before I start, though, I do want to make kind of clear that I am not an expert. I don't think there are any experts in the room. We are all learning in one way or another, and just because I'm on this side of the stream rather than on the other side of the stream doesn't give me any kind of authority over this whatsoever. I've designed this talk to primarily be a jumping off point if you're looking to set up a new project and you're wanting to embed DevSecOps. Within that process, here's a couple of things that you can think about while designing both your application and the pipeline itself. So yeah, I'm Sam. I'm a Geordie. Well, I was born in Gateshead. I live in Whitley Bay now. I've been doing software development of all sorts for 10 years. A lot of it has been behind paywalls and NDAs because I work for banks. I'm currently at Tesco Bank on Corn Business Park in Newcastle. I've been there since May, and that was quite interesting because that was in the middle of lockdown, and it was kind of day one. You walk into reception, they give you a laptop and tell you to go home, but it's all been fine. It's been good fun. And like I said, the vast majority of this talk comes from the previous project I was on when I was doing some consulting gigs, where I was responsible for a small team of DevOpsy folks, and we basically built the CI/CD pipeline and cloud infrastructure for a new product. And this is for it was a new kind of prototype MVP type application, but it was for a large UK financial institution who you will know of. I'm going to avoid kind of talking specifically about their stack or anything like that. I've genericized everything appropriately. So let's get the business buzzwords out of the way first. So we have this concept of DevSecOps, and yeah, it sounds a bit buzzwordy, but I think it is useful as a kind of industry term, because a lot of my experience has been security is something that happens right at the end of the process. It's some bureaucrat, securocrat in a different team somewhere else who will put a stamp on your project and say, yes, sign off, good to go. No, not good enough. And then you never hear from them again. Or maybe you hear from them every quarter or half year or year to do the annual pen test, and it bears no resemblance to what actually goes on. The whole point of DevSecOps, just like DevOps, is about embedding security throughout the process of building an application rather than waiting until the end. You may have heard this in the testing community as the concept of shift left, which is basically taking all that useful information that we generate and exposing it and making it available earlier in our development processes, giving it to the people who are actually empowered to make the changes where it's cheap to remedy, and actually in the context of security before it goes out the door and you're affected by it. What I want to do is kind of talk about the threat modeling thinking to go behind building a CI/CD pipeline. I'll be using kind of concepts from Stride, so spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. I think I got those right. All the way through in various examples, and I'm going to be pointing towards tools, both free and commercial and open source, which can kind of help you in each of the areas I identify. But if you're not familiar with the concept of a CI/CD pipeline, you may have heard of continuous integration, CI. This is where you have the process of everybody checking in code to a repository at least once a day, and then you'll typically have some automated build server which will compile your code, run your tests, and produce an artifact and stick it somewhere. Continuous delivery takes that one step forward, and it's about using these automated processes and tools to get your application into developer environments, into QA, pre-production environments, and then out to production. It's about making the entire process automated, repeatable, and scalable, so that you can deploy as often as you need to for your business, that you can continuously deliver value to your users, whatever that business value may be. And we're all familiar with tools to do this: GitLab, Jenkins, the new GitHub Action stuff, GoCD, which kicked off a lot of this stuff. It's an increasingly a very, very important tool in the software that we build. It's responsible not just for building the software, it's responsible for kicking off a lot of the quality checks that we perform. It will eventually handle our deployments, and in production, it doesn't just end there. It will very often perform ops monitoring or be able to hook into that stuff to know whether we need to roll back any changes that we put out. I like to describe it as the beating heart of the application. It's literally involved in everything. And when you draw these things out, what you end up with is almost like a diagram of steps that are performed, and you can do some of them in sequence and some of them in parallel. But in order to actually do that job of just building and checking the code and then deploying it, if you think of all the components it needs to touch, it needs to be able to pull in source code from a repository. It needs to then be able to push built artifacts, whether they're executables, binaries, or jar files or whatever. They need to push those to some kind of repository where they can later be accessed. And eventually it then needs to actually control your infrastructure. I've put up a few cloud providers here because that's kind of where everybody's moving these days, but it could be on-prem kit, it could be, I don't know, it could even be printing CDs or whatever. But the idea is that it needs to touch every single piece of your infrastructure in order to do this job. And it's good that we do this in an automated way rather than in a manual way, because if somebody's doing stuff manually, there's very little accountability at stake. But it makes this pipeline itself, as well as your application, as well as your kind of production infrastructure, this pipeline itself is a prime candidate to be attacked. And it can be attacked by external threats. These are clearly people who want to steal your source code or your binaries, want to find a way to exfiltrate your data, or just push malicious code into your production environment. Like, this is a really good way of hijacking what you put into production to run some crypto mining, for example, or to, I don't know, redirect transactions or gather stats or anything like that. You know, if you can hijack the vehicle that you use to put this stuff into production, well, you can get at everything. But it's not just external people we need to defend this system against. We need to defend it against internal actors too, both accidental internal actors and malicious internal actors. You have, in this case, all the same threats as external actors, but internal ones tend to have a bit more knowledge about how things are strung together. You need to make sure if something could be done accidentally or accidentally on purpose, that there are controls in place to prevent that. Somebody, for example, bypassing all of your controls to deploy a code change that they've made locally that hasn't been reviewed straight into production, and it does happen. Giving them direct database access and writing queries that they shouldn't be doing. You know, this stuff happens all the time, and people kind of justify it as we have manual processes around it. These are attack vectors and can get your organization and you personally in trouble. So they're really worth considering. But I want to break this down into the two components, because the pipeline is something that we should secure in and of itself. But I also want to talk about how the pipeline can be used as a way to secure your application. And obviously, security isn't a binary thing. It isn't something we have or don't. It's always going to be based on relative and absolute risks. So like I said earlier, I don't want to claim that you follow all these steps and you will be secure. I think these definitely put you on the right track to having some confidence that you have the appropriate controls and measures and stuff in place. So your pipeline is going to perform a lot of things. The type of things I'd be looking for in a decently built pipeline are secret detection. So the last thing you want, and I've had to correct this before in the past, it's a right pain in the arse, is if somebody commits some kind of secret information to your repository. Like, you can, with great difficulty, go back and correct that, but by and large, once you push something to a repository, if somebody else pulls it's kind of gone. And by secrets, I mean API keys, access tokens, client IDs, private keys. There are tools out there like GetLeaks, which can identify if a repository already contains secrets, and it's worth running them because you'll be surprised. The better tools out there, and GetLeaks also handle this, can run as pre-commit stages. So this is before somebody even pushes something from their local machine to the shared repository, and they can at this point intervene and say, I'm not allowing that to happen, you're trying to commit a private key. This goes a long way to making sure that secrets are properly handled and that you can't just kind of bodge them into the repository. And if you get the discipline right on this from the start, it's going to set you up very well for the future. Most of the software we build these days contains third-party libraries, third-party dependencies, open source components. And in large organizations, having oversight of that supply chain is really important, not just for security, but also to make sure that you're fully compliant with any licenses that you're subscribing to. Most pipeline tools will give you this kind of stuff for free. GitHub Actions, for example, has Dependabot built in. Dependency scanning is basically looking at all your third-party components, looking for the licenses that they use and reporting on those, looking to see if there's any security vulnerabilities. Most of the security vulnerabilities in these packages are already known and are already patched. So a lot of the time, what you actually need to do is just make sure your software is up to date. So they'll identify if you have unpatched dependencies. Dependabot will actually do that for you. It'll just, every time there's a new update to an application, it'll put up a pull request in GitHub for that individual dependency. But this is really good because it allows you to get from a point of just having an audit log of which dependencies do we have, what versions are they, to later on actually kind of enforcing compliance. If your tools can say we accept things that have the MIT license but not the Facebook bespoke clone of the MIT license, then you can stop these kind of libraries that are not approved from even getting into your process in the first place. So dependency scanning is really important. I'm going to be talking a lot about containers as well, because I think a lot of us are now using Docker images as a way of kind of creating a box that some software can go in, and then you deal with the box in a standard way. And because it quite nicely encapsulates all of your dependencies and the operating environment in which it runs, it's really cool. But containers in and of themselves can have security risks too. So there are particularly specialist forms of dependency scanning tools like Claire and the Claw integration, if you run a private Docker repo, to detect known vulnerabilities in base images. So if you're deriving from a particular form of Linux, for example, it may have some kind of unpatched security vulnerabilities in some of the more kind of fundamental libraries your application is built from. And again, from a license compliant and a security audit point of view, you need to have visibility of that. This will allow you to put in place the appropriate guardrails to allow you to make sure that everything you're using is up to date and is appropriately secure to the best of your knowledge. So that's the third-party stuff out of the way. Now we've got to talk about your own code. And there are various automated checks that a CI/CD pipeline will use in order to provide you assurances that you've not done anything we know about that's bad practice. The first one of those is static analysis, sometimes called SAST. This is where you have a tool like Spotbugs, which will look through your source code. It knows how to kind of understand Java or understand C, and it can identify where you've made potential programming errors which could lead to security vulnerabilities. And that can be as simple as detecting potential null pointers, out of bounds exceptions, memory leakages, all this kind of stuff. If you have that at the pull request stage, if you have that information when you want to merge a new change into your repo, and you can say, right, okay, we've got a couple of actions to take here. Again, really cheap to fix those. What you've got to be aware of with these static checks, though, is they know nothing about the context of your application. So you can get a lot of false positives that come from them, and they're not going to kind of intelligently be able to work out how to use your application and how to break it. But it's a useful first check to have. Once you get past pull request and once you're starting to put together some kind of release, you can use some of the more interesting tools out there, which fall under the category of dynamic application security testing, or DAST. Tools like OWASP SAP, because surprisingly, the OWASP top 10 is the top 10 for a reason. There's a huge amount of stuff out there that is still vulnerable to these basic cross-site scripting, SQL injection style attacks. DAST overcomes a lot of the shortcomings of SAST by actually running your application and then driving behavior dynamically, trying to inject security faults. And you can do this at various levels of tolerance with SAP. You're going to get fewer false positives that way. You're probably going to have a fair few security issues to deal with. But again, knowledge is power, and it's better to have these integrated and fixed. So that's the kind of stuff a pipeline can do for your application. But like I said earlier, the pipeline itself needs to be secured as well. So we need to look at kind of how the pipeline operates mechanically, what it touches, and then what considerations we have to take into account. We've got about 10 minutes left, so let's go for this. Securing the pipeline. Going back to this diagram, like I said, your pipeline touches your repository, it touches your artifact storage, it touches your production environments. So some of the things I'm going to talk about are about the pipeline itself, and some of them are actually about these related components. The first one is the repository. So your repository should have the appropriate controls on it to make sure that only certain actions can be performed in certain contexts. So what I have here is a typical kind of Git flow type branching model where you have a main, which represents what's currently on production. You may have a branch from that, which is your active development branch, and then individual devs may branch from that for individual features. Now, it makes sense that the feature branch could be potentially deployed to a dev environment without a huge amount of checks in place, because that's going to allow devs to get fast feedback on their work. It makes sense that only the main branch is allowed to go to production, and sufficiently advanced repository setups can enforce that only certain pipeline jobs can be triggered on the back of certain branches. And you can put in place controls to say, like, you can't force push to main, you need to merge to main via a branch, it needs to have a pull request, it needs to have a certain amount of approvers. So this can kind of make sure that code can only get to the appropriate environments, whether that's production or a test environment, if it's gone through the appropriate hoops in your process. The one thing that people tend to forget, though, is the whole idea of somebody forking the repository, because and that may not be external. That may be, if you're running GitHub Enterprise, you can take the shared copy of a repository and fork it into your personal space. You want to make sure that the pipelines aren't inherited by that, because they could then push to their copy of the repository into main and then deploy to production. So you need to make sure that the provenance increasingly common, and it's worth taking a look into one because you don't want the pipeline. So if your pipeline's running on a VM, for example, you don't want to have to run that as root. The other interesting thing about running Docker or building Docker images is that image tags themselves can be modified. They're just pointers to a particular image in your repository. So if you build something and sorry, Ben, do you have an issue there?
Yeah, the audio dropped out about 5 minutes ago. Well, not about 2.5, 3 minutes ago for
Crikey.
about a minute. Yeah, I've just fixed it, so you might want to recap the last kind of slide. Sorry.
Okay, what I'll do then is I'll start from the top here. So yeah, what I was saying before the audio failed me was that your Docker daemon, if you're building Docker images, runs as root, and that therefore there's a potential for the malicious code inside a container, whether you put it there or somebody else did, to break out of that container and then run as root on your machine. There are tools out there, for example, Google's Canonical Builder, and Podman, which run rootless, which is awesome because then that allows you to kind of have a bit of security when building those images. It's common when you build a Docker image to then tag it. Beware because tags are modifiable. They just point us to certain Docker images. So what that means is potentially if you build an image and then want to later on in the pipeline deploy it, that can be quite annoying because it could have changed. So Docker uses a concept of digests, like a SHA-256 fingerprint, and that gives you guarantees that that image hasn't been modified throughout your pipeline. So if you need that kind of reproducibility and auditability, then do that. 12-factor apps advise strictly separating your build and run stages. If you're using Docker to both kind of build and then specify how the app is going to be run, you can use the concept of multi-stage builds to separate out those two steps, and it means you're not bringing a whole load of extra dependencies into your runtime Docker container. Don't put any sensitive information into a container, don't put any passwords in, and don't mount sensitive directories as well. Your container scanning stuff should pick this up, but it's always worth kind of restating it. And if you're going to be deploying into something like Kubernetes, consider pod security policies, which can kind of enforce minimum security standards in any Docker images that you want to run, and custom admission controllers, because they can then check that, for example, the image that you're wanting to deploy comes from somewhere known and trusted. It's verifiable. You're not just trying to, again, yeet something into production. The big one is secrets management. To speak to all of these different systems, a pipeline is going to have to control a whole load of secrets. Now, the 12-factor app kind of ideals advise storing configuration in the environment. So you'd think, all right, okay, this is simple. I can just pass in stuff as environment variables. And sure, you can, but you've got to beware that that isn't foolproof. If you pass environment variables into a Docker image, they can be inspected quite easily. Because of the layered file system, you can kind of jump to the layer where the environment variable is being used, untar it, and read it. And you've also got to beware because certain applications, when they crash, will just dump the stack and the context, and you risk then dumping environment variables in plain text. The only time that in my opinion, environment variables or secrets of any kind should be stored in plain text as in memory, in the context of the process who needs it only. Every other time, whether it's in rest or in transit, it should be encrypted. So there are tools out there like Google Secrets Manager and GCP, Amazon Credentials and AWS, HashiCorp Vault, which is kind of my favorite tool, which allow you to kind of dynamically retrieve secrets at runtime. So your pipeline can make a call out to Vault, grab the secret that it needs, and then inject it into an application or use it to authenticate. Some of these can actually then rotate the secrets after use immediately, which means for each kind of request out to Vault or Google Secrets Manager or whatever, you get basically a one-time password with a short expiry. It's almost like pulling the lever on a Fruity and getting a new and unique credentials. So you really need to think about how the secrets are managed in your pipeline, whether it's passing secrets into running systems. So if you're running in kind of Kubernetes, for example, what I like to do is I like to pull files from Vault as a sidecar container, store them in memory, and then mount that in memory location to your other container so that the secret can be then read that way. And it's a pain in the arse, I admit, but it's much better than just passing plain text secrets around. Artifact repositories, right? We've already talked about Docker Hub. Where do you store the code? There are public repositories available, and sure, you can push to those. But running your own has a lot of advantages. You can trust it. It'll be on a private IP, so the fact that being able to attack that via DNS attacks is going to be significantly reduced. You can have access controls. You can use it to enforce your own license compliance, and in the event of something like LeftPad, where somebody just decides to delete or override a dependency in the public repository, you're not going to be bit by that. It allows you to build up like this golden source of approved, compliant, and known to be secure dependencies that then people can use. And again, from a compliance point of view, it just gives you that kind of surety that everything you're using is above board. Running out of time, so I'm going to go through this very quickly. The way that these pipelines will authenticate with all of these different systems is through service accounts. These are accounts in your systems that robots, non-human actors use. In some of the major cloud providers, the default service accounts can have a huge amount of permissions that they don't actually need. So what I'd advise doing is making sure that for any given operation in your pipeline, it uses a different service account, and that service account has only the roles that it needs to. But you also need to be aware that if a user triggers an action in your pipeline, such as deploy to main, you need to be able to, in your logs, associate the actions the service account performs back to a user, because it's useless to say that service account B1237 did this deployment. It's more useful to be able to know Sam was the one who asked you to do that. So this is your kind of repudiation actions. And then finally, I want to talk about the networking and the compute side of things. So where are your CI/CD pipeline agents running on? Are they running on VMs in your own network? Are they running in the cloud? Or are they running on the public machines that GitLab and GitHub offer? How secure those are differs massively. Some are going to be your responsibility, some aren't. I like to have different runners for different purposes. So the runners that have permissions to deploy to production, they can only take on jobs to deploy to production. They don't do building, they don't do scanning, they don't do anything like that. And that allows me to kind of lock those down in kind of bespoke ways. You've got to be careful when you have these pipelines that can deploy to dev and deploy to QA, deploy to prod, that you don't create accidental conduits between your environments. So if you do something like VPC peering in a cloud, what you're actually saying is there is a route between your different environments. So you have to be really careful and make sure you use things like access controls and firewalls to really monitor those conduits. And again, keep your build servers separate to what is in your production. Like, it's really easy to just have one big Kubernetes cluster that does your production, your QA, your UAT, your dev environments, and your build all through different namespaces. But that makes you really receptive to denial of service attacks. Or again, if something can break out of a container, it could then start to wreak havoc in your production environment. That's a lot to chew on. I appreciate in half an hour. Feel free to reach out to me on either my website, and you get my email address that way, or via Twitter. But I do hope that this has given you something to figure out. And do we have a few minutes for questions, or are you wanting to move on?
Theoretically, it should be a break just now.
Okay.
but it's a break for 15 minutes, and then we're into Adam Anderson's presentation. I guess if anyone does have any questions, do you want to jump into the Slido quickly?
Have a look in the Slido, see what we got.
There's nothing there at the moment, but I guess someone could have put in a question quickly at the end thinking, oh, I can get one in.
Cool. So, lots of good feedback in the Slack as well. Love for your talk. Slido is really quiet now.
I'm terribly sorry about the audio dropping. What I'll do is I'll upload the slides to something else that people can look over them again.
To be fair, chances are, given the way things have gone today, it's probably us, not you. So don't worry.
Maybe.
Listen, Sam, that was awesome. Thanks for that. Thanks for giving it. I know it's a lot to try and get. It's a lot for people to digest in half an hour, and I don't mean any insult by that, but it's also a lot for you to try and condense into half an hour and actually present in a meaningful way. So thanks for that.
Yeah, I mean, when I built the pipeline that this talk was kind of developed from, we had 3 months, and I was a complete noob at this stuff when building this. So a lot of it was speaking to a security architect. They would say, "Have you thought of this?" And we would go, "No, let's quickly go and build something to sort that out." And yeah, it's really easy with these tools to do stuff that is not that secure by default in really subtle and damaging ways if somebody can get in. Like the fact that Docker runs as root by default means that, like, if something can break out of that container, and doing that is fairly trivial these days, like there are known documented methods to do that. Like, your entire infrastructure is effectively owned at this point, because you then have a build agent which by default will have a service account with permissions well beyond what it actually needs. And yes, somebody can just go through and enumerate all your network topology, then get your database and get access to it, especially if the environment variables passed into it contain in plain text your database credentials. Like, it's terrifying that this can be done relatively easily.
Cool. Listen, thanks very much for speaking. Thanks very much for spending the time with us. We've had a blast. Please do hang around. If anybody does have any questions for Sam, I'm sure he would love to receive 1 million DMs from everybody. So do go and DM him. Do you have open DMs on Twitter? Just interesting question.
I will do in a few minutes.
you absolutely should. It's the best thing ever. You get so much crap on there. It's hilarious. But no, listen, I think so the other Sam